And these are the chapter 3.1 notes, functions and function notation. This is page 5. So example 10, A asks us to use function notation to represent a function whose input is the name of a month. So I'm going to make sure that I know what I'm talking about. So I'm going to call the name of the month M. Output is the number of days in that month. So let's call that D. So that's the number of days in the month. And so we want an input, that's the month. So I'm looking for F of month equals number of days. So in terms of my variables, F of M equals D. And if we needed an example, we could go F of January. And since there are 31 days in January, our output would be 31. B asks us to use the function notation to express the weight of a pig in pounds. So W equals weight in pounds. In terms of its age in days, which we're calling D. So our input is days, our output is weight. C says we've got a function n equals f of y, which gives us the number of Starbucks, which is n, in the state of Colorado in a year y. What does f of 2010 equals 208 represent? That means in the year 2010, there were 208 Starbucks in Colorado. Example 11. A little more numerical. We want to evaluate the function at the values given. So when x equals 2, and I'm going to blow these up so I can cram them all in. F of 2 equals 2 squared plus 3 times 2 minus 4. F of 2 equals 4 plus 6 minus 4. F of 2 equals 6. Where x equals a, and this is one you're going to want to get used to, we're going to do the exact same thing. We're going to plug a in everywhere we had an x, and we get f of a equals a squared plus 3a minus 4. So for C, x equals a plus h looks a little funkier. We're going to do the same thing. We've got f of a plus h. So a plus h in its entirety goes in everywhere there's an x. Okay. Now that a plus h squared, I'm going to multiply down here really quick. A plus h times a plus h. Firsts give us a squared. Lasts corner. Outsides, insides, and of course AH is the same as HA. So I'm going to rewrite. I've got f of a plus h here. I got a squared plus 2ah plus h squared plus 3a plus 3h minus 4. Notice that does not affect that constant at all. And so let's highlight answers here. There's our first one. Let's see if this helps us out in just a minute. Because look at what D asks us for. It asks us for f of a plus h, which we just calculated, minus f of a, which we got right here, all over h. And so this is something special, and we're going to see this a lot later on in this chapter. This is called the difference quotient. And for those of you going into calculus, this is a fancy way to find the slope. And it's the basis for the first half of calculus. Okay? So we are going to go ahead and substitute in what we have here. I've got f of a plus h, and I will try to color coordinate, and I'm going to go ahead and wrap this whole thing in parentheses so I don't get myself confused. So I've got my plus 3a plus 3h minus 4. And then it says we're going to subtract f of a. I'm going to put that in parentheses as well. That's a squared plus 3a minus 4. Right in under the wire, that is all over h. Let's see, here is my f of a. Here is my f of a plus h. So there's a couple things I want to point out to you here. The reason for wrapping them in parentheses is because that makes it easier for me to match up pieces that are the same. We are subtracting. So anything that looks exactly the same in the first set of parentheses and the second set is going to be subtracted out. So I've got a squared minus a squared, that goes away. 3a minus 3a, that goes away. And I have negative 4 minus negative 4. So you should notice that the entirety of that f of a, that original function, has canceled out. And so let's take a look at what we have left. I've got 2ah plus h squared plus 3h all over h. Here is the second thing you want to be aware of. Everything in the numerator has an h in it, so I can factor that h out. I'm left with 2a plus h plus 3 all over h. And so these h's cancel. And that is the second thing that should happen. That denominator of just h should always cancel. And we get an answer of 2a plus h plus 3. We'll see more of those later on in chapter 3. Example 12. Find the equation of a function. We've got a relationship 2n plus 6p equals 12 as a function of p equals f of n. P equals f of n if possible. This means solve for p, right? We've got p by itself on that one side. So that is what I'm going to do with this equation. I am going to move the 2n to the other side. And then I'm going to divide everything by 6. I got 12 minus 2n all over 6. If we want to separate that out, we can do the 12 over 6 part separate from the 2 over 6 part. 12 divided by 6 is 2 minus 1/3 times 10. They want us to call this f of n, so we're just going to rename it. A function in terms of n, 2 minus 1/3 n, which makes sense. I should have that same variable matching my function name. B, we want to use the function x minus 8y to the third equals 0. We want to express y as a function of x. Express y as a function of x. This means solve for y. And so that's what we're going to do. I got x equals 8y to the third. X over 8 equals y to the third. We can, just like we square rooted, we can cube root both sides. I get the cube root of x, and I'm going to separate it into numerator and denominator so I can simplify the bottom. Cube root of x all over 2 equals y. And so there is that one. C asks if we can rewrite the equation x squared plus y squared equals 1 in terms of y as a function of x. Well, let's see. We got to solve for y. So y squared equals 1 minus x squared. If I square root both sides, so square root, I get y equals, keep in mind, I added in that square root. So as I simplify, I need to remember that my right side has to have a plus or minus, which means y equals the positive 1 minus x squared. Y equals the negative 1 minus x squared. And notice something, if I plug in an individual x, I'm gonna get 2 different y's. Now keep in mind we're limited because what do we want to try? We want to try something that's going to give us a perfect square, but I got 1 minus something bigger that's going to be negative unless we have an x that's smaller than 1. But look at what happens if I use x equals 0.5 or x equals if I use x equals 0.5 in both places, I am going to get 2 separate y's. In this first one, I'm going to get the positive y. In the second one, I'm going to get the negative y, and that is a problem. So no, because 1x value, let's two different y values. A lot in these notes. Please take some time to back up and take another look at what you need to.